Refraction, diffraction, refraction of planes, fiber optics, exam questions, that's what we're doing. So single slit diffraction. When light is shone through a single slit, it diffracts and produces a distinct pattern. Laser light. Laser light is monochromatic and coherent. Monochromatic means that all of the light has the same wavelength, while coherent means they all have the same frequency and they have the same phase. If a wavelength of a laser light is roughly the same as the width of a single slit, we will see a diffraction pattern. So this is the diffraction pattern. So the light would go through the slit and it would make this kind of pattern, which would be bright and it would slightly dim with strips. So the image shows the pattern that we expect to see in a successful single slit diffraction experiment. We see a bright central fringe with alternating dark and bright fringes on either side. The black fringes are constructive interference, while the dark fringes are destructive interference. So white light, if we use white light instead of a laser, we'll be able to see a literal rainbow. That's because white light is made up of every other light and is not monochromatic. That means it doesn't have the same wavelength. I think that's what it means, same wavelength. Yep, genius. Each colour is diffracted by different amounts. So red is the longest wavelength, so it would diffract the most, while blue has the shortest, so it would diffract the least. Monochromatic means that the light is all the same wavelength. Coherent means the light is in phase and has the same speed. It's not speed, it's frequency. Filthy liars. So something light is the most diffracted. Red light is the most diffracted, and so appears on the outside. It's like the outermost part. So width of central diffraction maximum. So the width of central diffraction maximum varies with slit width and wavelength. If we increase the wavelength of an incident light, the width of the central maximum will also increase. That's because diffraction effects would also increase. If you think of a longer wavelength light, so red, being on the outside of a white light fringe compared to a shorter wavelength being on the inside, the intensity of the central maximum will decrease because the photons are more spread out. Slit width. If we increase the slit width, the width of the central maximum will decrease. That's because the diffraction effect will decrease. So imagine the widths become really large. The light will pass straight through and it won't be diffracted at all, while the intensity and the central maximum will increase because the photons are less spread out. So if you increase the wavelength, the intensity would decrease, but you'd get better results, but they're more spread out. Well, if you increase it, intensity decreases and they're less spread out, but they are just towards the wall. In a single slit diffraction experiment, what effect does increasing the wavelength have on the incoming light on the width of the central maximum? If you increase the wavelength, it would increase. Perfect. Diffraction gratings. When light is shone through a grating with slit width comparable to its wavelength, the light is diffracted into a pattern of bright and dark lines, maxima and minima. The bright and dark lines corresponding to where constructive and destructive interference has taken place. The positions are called orders. This diffraction has gone into many slits. Maxima and minima 2. On a screen there will be a central point. This point is called the zero order. The zero order line would have the largest brightness out of all the other lines, so the brighter ones. Either side of the central line lies on the first order line. The order line lies in the middle of the other two. The further away from the central point, the dimmer the lights are and the more orders are visible. Number of slits. The more slits in the gratings, the sharper the pattern of the lines on the screen. Simple. So the higher the order of maxima are, something brighter than the central ones. The higher order of maxima are less bright than the central ones. Okay. What is the zeroth order of the maxima? That is the bright central fringe. That says here, not zero, you liar. A slit must be similar size to the wavelength of the light in order to produce a pattern, a diffraction pattern. So pattern of diffraction. Explain what increasing the wavelength in incoming light of a single slit diffraction experiment will have on the diffraction produced. So if you increase the wavelength, then there would be an increase in the spread of the photons. That would also mean that there would be more diffraction, and the intensity of the central part would decrease because it's more spread out. The further from the center of the pattern, the dimmer the fringes get, because the main part is obviously the brightest part. So the longer the wavelength of light is, the larger the diffraction effect. So as you see here, blue is the smallest, red's the biggest. In a single slit diffraction experiment, what effect does decreasing the wavelength of incoming light have on the width? The width would decrease, but you're decreasing the wavelength. Simple. Now, diffraction gratings. And the end of topic test on diffraction. Diffraction grating equation. The pattern produced by a diffraction grating can be described by the diffraction grating equation. Diffraction gratings produced a pattern which is described by d sine x equals n lambda, where d is the distance between the slits and the grating, theta is the angle between the minimum and the 0th order line, so the maximum and minimum part of diffraction. The disabled h is the wavelength of the light, and n is the order of maximum. So slit spacing. A diffraction grating is made up of many slits. There are 1,000 slits per meter. Then slit spacing is 1 over 1,000 meters. In general, there are x slits per meter. Then the slit spacing is 1 over x meters. That would give the value of the distance. The variable n stands for the order of maximum. Knowing that d and h, we can predict the angle of the center of maximum. The central maximum is the 0 order, n is 0. This implies that theta is 0, which is what we'd expect. The first order of maximum would have n equals 1. The second order of maximum, n equals 2, and so on and so forth. Not every order. Remember, sine theta cannot be greater than 1. If you use an equation of sine, it can't be greater than 1 or less than minus 1. Conclusions. As we increase the wavelength, sine would increase, so the angle would increase, which means the pattern would become more spread out. If we increase the distance between the slits, then the sine decreases, so theta decreases, which means the pattern is less spread out. So that's the reasoning on why. So it's the diffraction grating equation. Theta is the angle between the maximum and which order? The 0 order. 0 order. As the wavelength of light increases, the reflection pattern becomes more spread out. Wavelength increases, the reflection pattern doesn't. It's the diffraction pattern. Simple. Derivation on grating equations. You need to be able to derive the diffraction grating equation. So, producing coherent sources. Light enters a grating as parallel rays and then diffracts through each slit. The slits act as coherent, which is in phase, and monochromatic, same wavelength, sources of light. These diffract waves then interfere with one another and produce a pattern. So, the angle of the first order. The first order maximum happens at an angle such as the path difference between two sources is one wavelength, lambda. Let's call this angle x. We just skipped a lot. So create a triangle. We create a triangle like shown above here. So we know the distance between the two slits is d. We know the path difference is h, or wavelength. And we know the angle is theta by geometry. So we know this is the angle right here. So then we use trigonometry to be able to solve the equation. SOHCAHTOA. then we know that the maxima always occurs for when the path difference is a whole number multiplied by the wavelength. Therefore, we can generalize the equation of the path difference. So a grating with more slits will produce more fringes, less fringes. A grating with more slits will produce longer, shorter, more spread out fringes. A grating with more slits will produce something. A grating with more slits will produce, it wouldn't be greater fringes, would it? A grating with more slits will produce something fringes. A grating with more slits will produce a diffraction, 1,000 slits, x slits per meter, variable stands for maxima, blah blah blah. Remember, no slits, you can by the equation, you don't want to exist, means patterns are more spread out, which means the pattern is less spread out. So, what does this mean if there's more grating? None of that helped. Like, none of that helped. More gratings, that's not gratings, that's not gratings, that's not gratings, that's not gratings. So, a grating with more slits will produce stronger. Nope. Sharper fringes. Stronger, sharper, really. So, what's the equation? So, path difference is that, because it's SOHCAHTOA. So, application of diffraction gratings. Diffraction gratings are very useful for physicists. Analyzing light. Diffraction gratings can be used to separate wavelength in light from different substances. The wavelengths presented can help us learn new things about the substances which are being tested. Atom spacing in crystals. Atoms in a crystal can act like diffraction gratings with little gaps for light to pass through. We can find the spacing between the atoms in a crystal by looking at how X-rays diffract through a crystal. So what roles can a diffraction grating perform? They can separate light, as it says here. It's pretty. So, uses: separating and analyzing light, and finding atom spacing from crystals, or in crystals. The slit separation is multiplied by the sine of the angle and is equal to the size of the fringe multiplied by its wavelength is equal to the amount equal to the watt of the fringe is equal to diffraction of the fringe. No, it isn't. So here it says where D is the maximum, H is the wavelength, and N is the order of maximum, equal to the order of the fringe. Yeah. A grating with more slits will produce sharper, not stronger, sharper. What is diffraction used to determine in crystals? It is used to determine the light, or the splitting out of light, finding atom spaces, and atom spacing. That's what is used to discover. So now the end of topic test on diffraction. What is the name of the process in which light spreads around a corner through or a gap? Diffraction. Simple. So what kind of fringes are caused by constructive? So these are light or bright, lighter. What kind of light is made up of all colours? White light. So if we increase the width of the diffraction slits, what happens to the central maxima? It would central maxima. So if you increase the distance, that means all the light would shine straight through. So that means it would increase. Decrease apparently. Oh yeah, because it would become less spread out apparently. If we increase the frequency of the incident light, what happens to the width of the central maximum? If you increase the frequency, it would stay the same. Frequency. Which line on a diffraction gradient pattern is the brightest? The brightest would be the zero order, it would be the white light. What happens to the brightness of a diffraction gradient pattern the further you go lower, higher. It can only be higher. What happens to the brightness of a diffraction grating pattern the further you are from the zero order line is... What's the opposite of brighter? Dimmer. There we go. That's the word I was trying. Where the following is the correct differentiation grading is this one. There is Sokotoa. Well, that is the order of maximum. What angle does the zero line occur at? 0, because it's the normal. What kind of photons are diffracted to investigate crystal structure? What kind of photons? Probably gamma radio. Oh. A diffraction grating has a slit of 700 nanometers. What time of EM waves would experience diffraction? Probably green light, considering it's the closest. So, what is the deviation of the grating equation? Light enters the grating as parallel rays, diffraction through each slit. These diffracted waves are then with each other, interfered with each other, produce a pattern. The first order maximum happens at an angle theta, and such a path difference between the two sources is one wavelength for constructive interference. We can create a something from the distance between the two slits. The path difference and the angle. We can create a triangle and use trigonometry. Apologize. We know that a maxima always occurs when path difference is a positive number multiple of x is a positive multiple of h, negative is a small, is a big, is a whole number, positive, okay, integer, that's what I would have meant, and that is diffraction done.